Good morning. As discussed, there were a few objectives that were not covered in class. We actually ran out of time. So I want to take the time to go over these key ideas as it relates to fractions. Please note, it is very, very important that you actually work through this entire video, that you complete the class activities that will be discussed, that you work the problems, and that you complete the reading in its entirety that's assigned throughout this presentation. All of those concepts and skills will be covered on Assessment 1, which covers chapters 1 and 2. So again, we briefly discussed contiguous and non-contiguous fractions. So what I want you to do now is I want you to work this problem. If 3 people were to share 2 small pizzas so that each person gets the same amount, how much would each person get? I just want you to take the time to work the problem out on your own. This is very important because when we assign problems to students, we want to have worked them so that we can kind of have an idea when we start to look at how their thinking actually is. So pause the video and work through this problem. Hopefully you've had the opportunity to come up with a solution, and I want you to imagine that you're in your classroom and you have 2 students, Mary and John, who both agree that there are 2 pieces that each person will get. However, their explanations are very different. John, a student in your class, feels that they would each get 2 out of the 6 pieces, so each person would get 2/6 of the pizzas. Mary feels they would each get 1/3 of each pizza because each pizza is the same size. They would get a total of 2/3 of a pizza. Who do you think is correct? Justify your decision. So I want you to pause the video, and I want you to take some time to think about which student would be correct and why. Can they both be correct? Well, in looking at Mary's justification, Mary has 2 small pizzas, and she's looking at each pizza as an individual whole. So there's 2 individual wholes that she's looking at. So with that stated, she's looking at one whole pizza broken into 3 parts for each person, so each part would be 1/3. So that means that she has another pizza that also is another whole that's broken into 3 pieces. So there's 2 wholes for a total of 3/3 and 3/3, or 6/3 total pizza. The 6/3 need to be divided amongst 3 people. So if we shared those 6 parts with 3 different people, each person would get 2/3 of a pizza. So Mary's correct. Looking at John's explanation, John looked at the 2 pizzas as one whole. He looked at, if I was to break those pieces up, I would have a total of 6 pieces between the 2 pizzas. So he's not looking at each pizza as being a whole, but he's looking at his whole consisting of 2 pizzas. So if those pizzas were cut up and combined, it would be a total of 6 pieces. So John is looking at each piece as representing 1/6 of all of both pizzas. So the 1/6 of the 2 pizzas that are combined make the whole. So each piece is 1/6 of 2 pizzas, not 1. So if he was to divide those 6 pieces with the 3 people, each person would get 2 pieces, but each piece represents 1/6 of 2 pizzas. So they would get 2/6 of the total slices of 2 pizzas, which is the same as 2/3 of 1 pizza. So they're both the same. The difference is Mary is looking at each individual pizza as one whole. So she's looking at the fact that she has 2 different wholes to be divided. John is looking at his two pieces as if I combine them into one whole, and then I'll have a total of 6 pieces in my one whole. So Mary is looking at this as individual contiguous wholes. In John's explanation, he's looking at the whole, the one whole consisting of two different or two non-contiguous wholes, if that makes sense. I would say, are there any questions? But of course, I can't get any feedback from you. But if there's any questions, I want you to write down your questions as it relates to contiguous and non-contiguous wholes, and to send me an email or to post it on your online discussion for other students to provide feedback on. So, fractions are defined in relation to a whole, as we discussed on Saturday. And this whole can be just one contiguous object, which we saw in Mary's case, where she was looking at just individual wholes made up of one contiguous object, or it can be a collection of non-contiguous objects, which we saw in John's case, where his one whole was made up of two non-contiguous objects. You do not need to look at class activity 2I, I don't think. Let me see here. I'm sorry, yes, please do. Review, and complete class activity 2I at this time. So pause the video. And also, once you're done with that, you can take a look at page 55, number 6, page 58, 12 through 15, and 17 through 20 to get more practice with identifying the difference between contiguous wholes and non-contiguous wholes. Okay. I want you to look at this problem. Just as you may go to the pizza and there's small, medium, large, there's pies that are small, medium, large. 8 sisters want to equally share the 3 pies that are pictured below. What fraction of the combined amount in the 3 pies would each sister receive? Explain. So I want you to pause the video and I want you to think about this. There's 3 pies there. How much would each sister get? Hopefully you've had time to work through this problem. If I was to break the large pie into 8 equal parts, I will break the medium into 8 equal parts, and I'll break the small into 8 equal parts. Because of course, I cannot just combine those pies. I will need to break them into individual pieces and share them accordingly. If I'm sharing them equally, that means that I can't give one sister all large pieces and another all small, because that would not be equally. So in order to share this equally, I would need to give each of them one slice from each pie. So 1/8 of the large, 1/8 of the medium, 1/8 of the small would be 1/8 of the entire combined amount of pie. Each sister would get the same amount. These are just additional questions for you to consider. And if you would like, you can email or post to the online discussion. Again, this is also in the text. So as you're reading, you should come across in chapter 2, I believe section 2.4, no, 2.2. You should come across a section that actually discusses what to do when you are equally sharing a set. See, this whole here is made up of 3 non-contiguous objects. So this whole needs to be shared. So in order to share it equally, you would have to divide each one and then share each part. So you can actually share when there's different sized objects. Okay, I want you all to take a look at class activity 2E and work through it. And 2E actually will provide additional practice as it relates to fractions that consist of a set of non-contiguous objects. Okay, So now that you've had a chance to practice and work with understanding the difference between a whole that is just made up of a contiguous object and a whole that is made up of multiple non-contiguous objects, I want us to move forward in looking at converting fractions to decimals without using the traditional division algorithm. So I'm going to start off with this fraction, and of course from our class on Saturday we talked about the important part of properly describing the fraction or the symbol that represents 3/4 and stating it as being 3/4. So if I'm trying to actually convert this fraction into a decimal, what I want to do is I want to start off with one whole. So in this case, the flat is one whole. I'm using the flat that's made up of 100 as one whole because that way I can actually divide that whole into decimals or into partial parts that will give me the decimals. So that one whole is like one whole dollar that I want to break into dimes, which would be tenths, or pennies, which would be hundredths, and so forth. So in this case, I'm working with one whole or $1, and I want to find out what 3/4 of that one whole would be. So as previously discussed, 3/4 is the same as 3 copies of the unit fraction 1/4. So what that means is if I can find 1/4 of a whole dollar, then I can just copy that 3 times to find out how much 3/4 would be. So in this case, I have one whole, and I would need to divide it equally amongst 4 groups in order to find out what 1/4 would be. So I can't physically share that one whole with those 4 groups because it's only one object. So I would need to exchange that $1 or that one whole for 10 tenths or 10 dimes, which can be shared. Those 10 objects can be shared equally with the 4 groups. Okay. But now I only have 2 tenths or 2 dimes left that cannot be shared equally with the 4 groups. So I would need to exchange those 2 tenths for hundredths. So I could take 1 tenth or 1 dime, and it's the same as 10 pennies or 10 hundredths. I can do the same thing with the other tenth. I could exchange it for 10 hundredths or a dime for 10 pennies. And now I have a total of 20 hundredths that can be shared with the 4 groups. So each group would get 2 tenths and 5 hundredths. And if I wanted to know how much would be in 3 groups, it would be 3/4 or 75 hundredths. Now, one thing that we're going to also look at is percentages. We no longer have to tell students to move the decimal 2 times to the right and so forth to find out the percentage, because percentage means per hundred. So in this case, 75 hundredths is 75 hundredths. So I can replace the word hundredths with percent. It's the same as 75%. Now, just as I can use base 10 blocks to convert fractions to decimals, I can also use a number line. So, for the same fraction 3/4, if I was to divide in order to see what 3/4 would look like, I would need to identify my unit fraction of 1/4. So I would break the 1 unit into 4 equal parts. And then I know that from 0 to 1 is 1 whole. Well, that 1 whole can't be divided amongst those 4 parts, so I'm going to exchange it for 10 tenths. Now notice my fourths, my 1/4 and my 3/4 actually lies between or in the middle of 1/10. So I'm going to need to break that tenth into 10 smaller pieces or into 10 hundredths. And in doing so, if I was to share it into 2 equal groups, each group would get 5 hundredths. So each fourth is made up of 2 tenths and 5 hundredths, or a total of 25 hundredths. So if I wanted to know what 3/4 would be, I would start off with the fourth, which is 25 hundredths, and I would do 3 copies. So 3/4 on my number line would be 75 hundredths, which again is 75% if I was to replace the word hundredth with percent. Let's try another example. Oh, before we try another example, let's look at converting the decimals. So we've looked at converting the decimals with base 10, the number line. Let's look at looking at it from the perspective of the 10 by 10 grid paper, which is also a pictorial that represents one whole, the flat that has the 100 small squares. So in this case, if I was to physically color in and divide this amongst 4 equal groups, I can start off by saying, oh, one group will get a tenth, 2 groups, 3 groups, 4 groups. So then I'm going to start over again and say, okay, one group can get 1. And then I'm left with those 2 tenths. Well, I noticed that I can actually break each of those tenths in half and share it with the 4 individuals. So each person will get. So if I was to put the colors together, it would look something like this. Each fourth represents 25 hundredths. 3/4 would be the pink, the green, and the blue, which is 75 hundredths. Let's try another example. 2/5. And looking at 2/5, I'm going to start off again with my flat or my one whole. And I want to know what 2/5 looks like. So first I need to find out what 1/5 looks like. And in order to find out what 1/5 looks like, I would need to divide that 1 into 5 equal parts. So there's my 5 equal parts. I cannot physically share that one object with those 5 parts. So I'm going to exchange it for one whole for 10 tenths. Now I'm going to share them. So each fifth gets 2 tenths or 2 dimes, which would be either 2 tenths or 20 hundredths. So 2/5 would get 4 tenths or 4 dimes, which can be the same as, if we know that each dime is the same as 10 pennies, 40 pennies or 40 hundredths. And the reason why I'm putting hundredths is because to write a percent, you just replace hundredths with percent, because percent is per hundred. Okay, I'm going to do the same thing as before with this one and looking at how to use a number line to convert 2/5 to a decimal and then a percentage. So again, 2/5, I would need to know what 1/5 looks like. So I would divide my one whole into 5 equal parts. And I know that one whole is made of one whole. In order to divide that whole up, I would need to exchange it into 10 tenths. And notice, each fifth is 2 tenths. So if I wanted 1/5 is 2 tenths. So if I wanted 2/5, it would be 4 tenths, 40 hundredths, because each tenth can be the same as having 10 hundredths or 10 pennies, which is 40 cents, 40 hundredths, or 40%. I'm going to also use the 10 by 10 grid like previously to show how 2/5 can be also converted to a decimal. So in this case, one person gets a tenth, 2 persons, 3 persons, 4 persons, 5 persons. I have 5 more left to share, so that means that each one would get another tenth. So you can actually have students use colored pencils to do this. Some students may actually divvy up each individual square, writing a 1, 2, 3, 4, 5, and doing that all the way through the 100. However they do it, let them do it, and then have them reorganize the colors together so that then you can see that each fifth is 2 tenths or 20 hundredths or 20%. So I've briefly talked about percent as meaning per hundred. What I want you to do now is to explore class activity 2T. Okay, hopefully you've had an opportunity to look at 2T. I also neglected previously to ask you to practice converting fractions to decimals using base 10, as well as to using a number line, as well as using the 10 by 10 grid. So I would encourage you at this time to come up with maybe 3 or 4 fractions and use those 3 strategies for converting the fraction to a decimal and a percentage. I would also encourage you to explore why 1/3, the fraction 1/3, is a repeating decimal. So I want you using the 3 strategies to also explore and to write out the fraction 1/3 and to convert it and to be prepared to explain why it is a repeating decimal. Okay, so in summary, percentages are like fractions, special kinds of fractions. Every fraction has a decimal representation. Therefore, every percentage has a decimal representation. So our study of percent extends our study of decimals and fractions. So we've taken a look over the course of the last 3 classes at whole numbers, decimals, numbers, and fractions, and percentages. So we've taken a look at all the different representations. Now that you've had an opportunity to explore the equivalence between fractions, decimals, and percents, I now want us to explore a way of converting fractions using reasoning. I want you to tell me, as I'm going through the video, I want you to take time. It's going to go kind of fast. I want you to be able to identify which fraction is greater without using common denominators, converting to decimals, cross multiplication, etc. The key is to think through comparing fractions without using the traditional converting each fraction to a common denominator, or converting each to a decimal and then comparing the decimal, or the cross multiplication. Okay? Here's the first one. Which is larger? Circle. Just using reasoning. And write these down so that you can revisit them later when we're discussing the different ways to reason about fractions. Second one, which is larger? Really quickly, circle. And write it down to revisit it at a later time. What about this one? Which is larger? And how do you know? Again, write these fractions down because they will be referenced later in the PowerPoint presentation. Circle the greater of the two. 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 Do the same. Do the same for this one. Circle the greater of the two. And last but not least, circle the greater of the two. Please make sure you've written down the comparison of each fraction set to reference at a later time. Okay? And for those of you who did not get a chance to write it down, here's A through L. Please make sure that you write down these fraction comparisons to be discussed later. Make sure you've also circled your fraction. And the reasoning used did not involve using common denominators, converting to decimals, or cross multiplication. Okay? Now I want you to stop. And I want you to read section 2.4, complete class activity 2Q through S. Then I want you to go back to the fractions that you just compared, and I want you to check your answers using the strategies that the book discusses. You can pause the video and then play it back once you've completed your reading and activities. Okay, I am going to summarize the strategies that the text actually talked about in using to compare fractions. These are strategies that we want to equip our students with so that they're not spending too much time with procedures and doing math exercises that require a lot of time when that time is not necessary. So in this case, I have 4/5 and I have 4/9. Well, one thing that's in the frameworks that we should help students see and highlight is helping them to understand what a fifth is in comparison to 1/9. There's that unit fraction again. A fifth in relation to a ninth. Students should understand that dividing a whole amongst 5 in comparison to dividing a whole with 9, the whole that was divided amongst 5, each person would get more than the whole that had to be shared or divided amongst 9. So they should understand that a fifth is larger than a ninth. So if I have the same number of pieces and I have 4/5 in comparison to 4/9, I would know that my 4/5 is larger than 4/9 because each fifth is larger than a ninth. So that strategy that was discussed in the text is called same number of parts, but parts of different sizes. So if you know that each part is larger, then if you have 4 larger pieces than 4 smaller pieces, your larger pieces would, of course, be the larger of the two, which would be 4/5 is larger than 4/9. 4/7 in comparison to 5/7. In this case, we should know that if I have a seventh and I have 4 in comparison to having the same size seventh and I have 5, then 5/7 will be more than 4/7. More of the same size parts. Again, this is why it's so important for students to understand unit fraction and and fractions being represented by multiple copies or multiples of the unit fraction. So the book talked about more of the same size parts. In comparing these two fractions, 3/8 or 4/10, in looking at an eighth and in looking at a tenth, I know that an eighth is larger than a tenth, but I have 3/8 and I have 4/10. So I really can't use the other strategies previously discussed. But I can look at that fraction and I know that 3/8 is 1/8 from being a half, and I know that 4/10 is 1/10 from being a half. So then I can look at this and say 1/8 is larger than 1/10. So what that means is 3/8 is farther from a half than 4/10. So in this case, 4/10 is larger than 3/8. So the book talks about this in looking at fractions as it relates to closeness to 1/2. If you're still unclear, please revisit the reading, access the online discussion, or send an email or text to me. What about 8/9 and 7/8? In this case, each fraction is one part from being a whole. So 8/9 is 1/9 from being a whole. 7/8 is 1/8 from being a whole. Well, we know that 1/9 is smaller than an eighth, so 8/9 has to be closer to that whole than 7/8 is. So that's closeness to a whole. In comparing 5/8 or 6/10, they're hard to compare, and that's what you'll find. Some fractions are hard to compare. We can't use the same number of pieces because the numerators are different. We can't use the same size pieces because the denominators are different. And in this case, if we're trying to compare these fractions to one whole, 5/8 is 3/8 from a whole, and 6/10 is 4/10 from a whole, so that doesn't help. But we can notice that both fractions are 1/8 or one piece more than a half. So in 5/8, 5/8 is 1/8 more than a half because a half is 4/8. 6/10 is 1/10 more than 5/10. So 5/8 is 1/8 more than a half. 6/10 is 1/10 more than a half. So we know that an eighth is larger than a tenth. So that means that 5/8 is closer or further from a half than 6/10. So 5/8 will be closer to 1 whole than 6/10 would be. So 5/8 would be your larger fraction. We want to encourage students to use this type of reasoning when comparing fractions. So the most important reference point of benchmarks for fractions are 0, 1/2, and 1. Please help students to begin to think about fractions in relations to those numbers. Okay? So again, this is just a summary of the different reasoning strategies that you read about, that you worked through on the task, and gaining an understanding of how to compare fractions. Now, in addition to these strategies, the book discusses the idea of converting to decimals. If it's something that can easily be done or students can understand, they can convert to decimals in comparing fractions. So if we were comparing the fractions 1/2 and 3/5, the important part is to make sure that you do a double number line or a number line in which both fractions are compared in relation to the same whole. So in this case, I took a half. So a half would be 5/10, and we've looked at how to convert fractions to decimals. So that's 5/10 is a half, and 3/5 is 6/10. So in this case, 3/5 is closer to 1 whole than 1/2. So 3/5 would be your larger fraction. The book also talked about cross multiplication. Cross multiplication, I want you to pay very close attention. Some teachers say that it's like the shooting stars where you do cross multiplication, you get an answer, and whichever is the largest is your actual answer. Well, what you're actually doing in cross multiplication is you're getting a common denominator. So you multiply the 1 by 5, but you also multiply the 2 by 5. You multiply the 3 by 2, but you're also multiplying the 5 by 2. So that's 5/10 in comparison to 6/10. A lot of times we would just have 5 and 6 and say that 5 is less than 6. No, please encourage students to use common denominators and see that 5/10 is actually less than 6/10. Okay, homework, as previously stated. Also, you have a total of 2 weeks before the online assessment is due. Please do review all information, work through the problems, and be prepared before accessing Assessment 1, which is chapters 1 through 2.